Hi everyone, I'm a researcher at Massasoit Community College in Massachusetts, and today I'm going to be using examples from the project I am currently involved in to talk about the choice of spatial scale, particularly in an urban ecology study. Now before we begin, what is a spatial scale? Well, a spatial scale is simply the amount of land you wish to analyze, also referred to as a buffer. If you consider your study site that point on the picture, then all the area inside that circle would be the land you wish to analyze. To actually analyze that land, studies will employ geographical information systems, or simply known as GIS. On the left here, you have a typical map that represents how the land is being used. Now, with a program like QGIS or ArcGIS, you can extract only the land in your spatial scale to an Excel file. From there, you can manipulate it, which is most commonly used to find out how much of a land attribute makes up your study site. And because of this, GIS is very important for many ecological studies. Without it, you'd have to analyze the land based on a satellite image, like the image on the right. This is possible, would be time consuming and tedious. Now, why am I bringing this up? Well, with the ease of automation, there are some potential downsides. Since it's so easy to generate scales, this may lead to scale choice being more of a post hoc decision. This could also lead into potential inconsistencies among studies as well. And currently, there is no agreed upon scale to use. Most studies will either justify their own scales or cite other studies for a scale to use. Some studies will even pick multiple scales. With all these different scales being used, one question arises, and that's how does this change your study? Now, what would happen if you picked only one scale? How would that scale choice change your results? If you only picked 300 to, let's say, something like 800. Well, to test this, I'll be using B-data from an ongoing survey from 2016-2019 in southeastern Massachusetts. 3 commonly used scales were chosen, that being 300, 500, and 800 meters for 6 study sites. Some studies will use scales that are smaller, and some will use scales that are larger, but these should give a good representation for most studies. And for the land attributes, I'll be using percent forest cover and percent impervious land cover, 2 commonly used land attributes. Now, the scale you use certainly has an impact on the composition of the study sites for both forest cover, which is on the left, and impervious land cover, which is on the right. Now, while there are no major spikes or drops, there's also no flat lines either. So if even by a couple of percent, their composition is changing across scales. Now, how would this change something you base your conclusions off of, like a statistical test? Well, scale had a noticeable impact on the strength of the correlation. On the left, you have the correlations between bee abundance and forest cover, and on the right, between bee abundance and impervious land cover. And then it's split up by 800 meters on the bottom and 300 meters on the top. Now you can see that the correlations at 800 meters are a lot stronger than at 300 meters, with around a 0.63 for the R-squared value compared to a 0.26 for forest cover. Now I did not include 500 meters there, as there was a trend that the larger the spatial scale, the stronger the correlation. So 500 meters would fall between 300 and 800 in terms of strength. So with this, you can say that picking 800 over 300 would give me a lot stronger conclusions. Now, while this is not necessarily a difference between multiple scales, another potential change would be in the results, and your results would be the point of origin for your study sites. This is essentially how you classify your study site and what you're drawing your buffer around, or your spatial scale. These are 300-meter buffers with different origin points, and the potential inconsistency lies in the fact that these are often not reported. And while it's not a major change, as the different origins only change by about 1% or so for something like impervious land cover, there is a certain difference. The first view is just a simple point, which is what I believe most studies to be doing. But again, as I mentioned, there's no real way of telling. For transparency, this is what I use for my analysis. Depending on your sampling technique, you may want to pick multiple points. If you're using a pan trapping technique, you may say that each pan trap is a representation of your site, equating to multiple points. Similarly, if you use a sweep netting technique, you may use a transect instead of a dot, which makes sense considering along that line is where you'd be catching all of your specimen. But regardless, now I've talked a little bit about how spatial scale can change your results. How do the other studies end up justifying what scale they pick? Well, for many studies that use multiple scales, they'll generally pick the scale with the strongest correlation to base their conclusions off of. So for my study, I would draw all my conclusions off of my results for 800 meters. Now, this is not without its own potential criticism, however. If the goal is to use a scale that best represents your organism, then how could you say it's at the strongest correlation? There could be a case where an organism is truly unaffected by a certain land attribute, but for whatever reason has a strong correlation at certain scales. Now, there are some statistical tests that may address this, like a potential Bonferroni correction, though these are often not used. Also, cherry-picking your scale could lead to hard-to-defend conclusions, which may address conflicting results among papers testing similar things. For example, some studies will say that impervious land cover negatively affects bees, while some say there is no relationship between the two. But that's for multiple scales. Now, how do studies that pick a single scale justify it? Well, studies that use a single scale will generally pick it based off the flight range for bees. Here I have two bees with an estimate of their flight range. On the left is a bombus species that can go around 100 or 1,000 or so meters, excuse me. On the right is an Andrena species that can fly around 500 meters. As you can see, those are two very different flight ranges. And while you may not necessarily have these exact two species in your study, the common trend is that bees have a very diverse flight range. So generally speaking, you will have two bees in the same study that have very different flight ranges. So how do studies alleviate that? Well, they end up using a mean flight range of bees, which tends to be around 500 to 800 meters. A potential issue is that if you're analyzing all your bees at once, a one-size-fits-all solution may not be the most accurate. If 800 meters is the mean flight range, and you analyze the spatial scale, you're potentially analyzing more land than some species are impacted by, and inversely, not enough land for some other species. Potentially splitting up the bees based on their flight range may be beneficial. So instead of one big analysis, you have multiple smaller ones. And while I don't think either of these justifications, that being picking the strongest correlation or using flight range, are invalid in any way, they certainly do have their own pros and cons. And I think researchers that are looking for a scale need to take that into consideration. So now I've talked about how scale can impact your study and some of the justifications. What scale do you pick? Well, I wish I had an answer for you, but unfortunately there's a lot to picking a scale. Here are some of the factors that I think you should take into consideration when choosing a scale, whether you're picking multiple scales or a single scale. One would be taking into consideration where your study site is in the general composition of that study site. Generally, with more urban studies, or more urban sites, they change their composition rapidly by going from a city center to a forest and then back to a city as you increase the amount of land you're looking at. Well, something like a rural site may just stay forest for a very large area. What that means is going from 100 meters to 200 meters for an urban site may be more noticeable than a rural site. This is a similar concept to my next point, which is what land attribute you'll be looking at. If your study site is composed of the same type of land attribute for a very large distance, then potentially choosing, let's say, 300 meters versus 500 meters may have no effect. To really see an effect between different scales, you're going to need to see that composition change. The organism you're sampling should also have a say in what scale you choose. Using an organism trait, like for instance bee flight range, can help you understand at what scale an organism is being affected by land attributes. And lastly, the origin point for your study site. Again, this won't be a major change, but it's really dependent on how you define what is your site. Maybe a single point, or it could be a transect, or it could be multiple points. So overall, what are some of the key points that I hope you'll be able to take away from this talk? Well, for this study at least, the choice of spatial scale had a noticeable impact on correlation strength. And this way of analysis by testing multiple scales may prove to be useful for other studies as well. Multiple scales may need some statistical tests done on them on their results to avoid any potential reproducibility errors. And this again could be addressed by a Bonferroni correction or another type of statistical test. And while I did say that using an organism's trait is helpful, Incorrectly using that trait may contribute to misleading results. Specifically, if a bee being analyzed has a flight range of 1,000 meters and you use a 500-meter buffer, then you may not have the most accurate conclusion. And while there may be no clear solution to picking a scale, I'm hopeful my talk helped you understand how important spatial scale choice is, and how, of course, more justification for experimental design is never a bad thing. Thank you for listening to my talk, and I would appreciate any insight if you had some on this specific topic, or if you had any questions for me. I would like to thank all the people who helped me directly with this talk, and thanks to Massasoit Community College for their STEM program, and the Mass State Legislature for funding with the STEM Starter Grant. And thank you, of course, for listening.